Yeah, good morning, everyone. We'll start within 2 minutes. Let the people join. Raju. Yes, very good. Good morning to everyone. So we'll start with our class. I'm going to share my screen. As before we start with our today's topic, so some announcement. As you know, today is 27, and your last date for your submission of this, those who are eligible for the free ship or scholarship through DBT. So you have to complete your forms properly in proper manner. If there are any sort of say discrepancies, so please immediately contact to student section. So already the numbers have been shared. Student section, Mr. Deepak Tandale or Sudarshan Gaikwad. So and one more thing, the message from student section is there are some students who have not submitted their original documents. So these things all you have to complete before 31st. If anybody is having any sort of say pending fees also, so that also you have to complete because you have to upload the entire fee receipt on your DBT portal. Okay, so please ensure about these things because these are very prioritized work that you have to complete before 31st. Afterwards, it becomes very difficult. Otherwise, there may be a cancellation of admissions also. So to avoid all these things, you have to be very precautious. Today is 27. So if any sort of difficulties are there, you can contact to me also. So that means we can be able to resolve some difficulties up to our level so that you can be comfortable up to 31st. Okay. So now, and regarding your CA examination, so as per the academic calendar, your CA is scheduled between 4th and 5th of February. Okay, and your syllabus for the CA examination is first two units, unit number 1 and unit number 2. So CA will be conducted only for the theory subjects, not for the practical. Okay, please remember only for theory subject the CA examination will be conducted, and that will be of 15 marks each. So by today, most probably you will get the notice regarding in which manner we are going to conduct the CA examination, whether it will be online or it may be offline. So whatever the message that we will get from the higher authority, we will communicate you accordingly, and you have to start your preparations. Okay. So this is regarding, even though if it is online, you have to solve manual paper and then you have to upload it on a Google Classroom. Okay. So please ensure about these things. It is not like you will get the MCQ questions and you will just go on tick and you will get the marks. So you have to thoroughly study and you can be able to answer these questions. Okay. So please ensure about this thing. So these are the some instructions. So those who have joined late, still, once again, I repeat the instructions. Number one is your last date for your DBT, that is scholarship or this freeship forms, to submit online as well as keep a copy of that. So that means if any sort of discrepancies are there, so you can be able to resolve it before 31st. Okay. Student section contact details are also been shared, Mr. Deepak Tandale and Mr. Sudarshan Gaikwad. So you can approach to them, even though directly you can approach to your teacher guardian also. So that means they can be able to communicate in between you with the student section. Okay. And then third instruction I given regarding your CA examination. So that was scheduled between 4th and 5th of February, and which mode, so that we will communicate by notice, maybe by today or at most. Okay. So with this, now we will start with our syllabus. So as you know, the syllabus for CA, that is Unit 1 and Unit number 2. So Unit 1 already been covered, as well as the several times revision also we have taken. Then Unit 2 we have started as optics. So that also the revisions, every lecture we are conducting the revisions also. So now there are some last topic that we have to complete. So that first we will complete that, then we will go for some revision of this also. Okay. So now in this optics chapter, first we have completed with the uniform thickness, that is thin film, and then we have moved to the non-uniform thickness. So in non-uniform thickness, the example that we have discussed, that was air wedge experiment, and then we have started with the Newton's ring also. So I will directly move to the Newton's ring right now, because we will revise that and then we'll move to the last part of this unit. Okay. So let's start with the Newton's ring. So Newton's ring, what exactly? As the name, you can be easily understand ki the ring, the pattern that we will get here is the ring pattern. Okay. The ring structure. So you can see at the side here the fringe pattern that appears to be a central spot, dark, and with the surrounding rings. And you can look the pattern closely, so that if you can observe the pattern, it looked to be like it is not the equidistant. Please ensure about this thing first. It is not the equidistant. If you are toward the center, the distance between the fringes is larger, and if you are away from the center, the distance is narrow and narrow. Okay. So now, why such type of pattern that we will get in Newton's ring? So that we can be able to discuss here. Okay. So this Newton's ring is an example of non-uniform thickness. Okay. So how you can be able to get the non-uniform thickness? So for that there is an assembly part. So you can see here the assembly that consists of a glass block. So while writing answer for Newton's ring, so what you will write? See, consider a glass block. Okay. So first what you will write? So consider a glass block which is placed at the bottom, and above this glass block there is a plano-convex lens. Okay. So the plano-convex lens means, you can elaborate that also, ki one side is a convex and the other side is a plane surface. So therefore it is known as plano-convex lens. Okay. So you have to place this plano-convex lens on the glass block in such a way so that it can make a contact at point. Suppose you can denote this point as O. Okay. So wherever there is a point of contact, that can be a O point. Okay. So this plano-convex lens and the glass block, they make a contact, and due to this there is a gap which has been formed at the both side. Okay. So you can see there's a gap here as well as on this side. So on left hand side as well as right hand side, there's a gap which has been formed, and there is nothing. So this gap which has been filled up by the air medium. Okay. So air medium, and if you observe the thickness of this gap, so you can see at the point of contact the thickness of this film area, that is almost zero. So that almost zero, we can call this as a T is very less than lambda, and it progressively increasing toward the other end. Okay. So if the thickness is almost zero at one end and it progressively increasing toward the other end, is known as wedge. Okay. So here also the air wedge between the lens and the glass block has been formed. But only the difference between the previous example and this, here the arc is been formed. Okay. The arc structure, in previous there is a straight path. Okay. So it was exactly a straight, but here there is no straight, there is a curve part. So what will happen here? Every time there's a curve part, so the pattern that you are getting is because of a particular thickness. Means if one particular in case of say um, this magnetic field, the transverse magnetic field, there also we are getting a circular path. So why circular path? Because the locus is at the center. So whenever you see locus at point, suppose say O with the glass block, and at the sideways means on left hand side and right hand side there is a gap which has been formed, and this gap which is filled up by the air medium, and it appears to be like a wedge because at the point of contact the thickness is almost negligible, that is zero, and it progressively increasing toward the other end. So therefore it has a structure of air wedge. So it is, and it also satisfies the condition of thin film. So therefore it is known as air wedge or the air thin film. Okay, so this is what the assembly. And then we have other arrangement, that is a sodium lamp as a monochromatic source of light. So through this sodium lamp, the broad extended monochromatic light that will incident on the convex lens. Okay, so the convex lens, the purpose of this convex lens is to convert this extended source of light into the parallel form. Okay, so from this convex lens the light will come in a parallel form and it will fall on the reflector, the light reflector, or you can say that there is a simple glass slide, that glass slide which play a role of light reflector. Light reflector, it means once this beam of light, the parallel beam of light will incident on the glass slide, so it partially reflect the light and transmit also. So you can see the reflection arrow is in a downward direction, and once it will reflect and it will incident on the plano-convex lens, so it should incident perpendicularly, means normally, you can say perpendicular or normal. So due to this purpose, this glass slide is maintained at an angle of 45 degree. Okay, so you have to maintain this glass slide at 45 degrees so that your reflected light will incident normally on the plano-convex lens. And after that you can see there is a going arrow also, one is coming, another is going arrow. So the both arrows that we have mentioned, one is which is incident and then it get reflected back. Okay, so there is a reflected back arrow, and then after reflection they will reunite at this point, and that reunion can be able to see through the microscope. Okay, so the two ways they reunite, either they reunite means interfere. Okay, so their interference, it can produce a constructive or it can produce a destructive interference. So that kind of pattern that we can be able to observe through this microscope. Okay, so microscope which has an eyepiece, so that means you can be able to see the clear visible pattern. As this entire pattern, that is a fringe pattern that is observed on the top surface of the plano-convex lens, so therefore it is called as the localized fringes. Okay, some important point that we have discussed in last lecture. So similar these points are also applicable here. Key number one is why the center spot dark? So why the center spot dark? It is simple answer. Ki at the center, the point, it is a point of contact. The center point is a point of contact, and due to the point of contact, the thickness of the film is very less than lambda. Okay, that is T is very less than lambda. That you have to mention. Once it is satisfied, then your the optical part difference, that delta comes out to be lambda by 2, so it satisfies the condition of destructive interference. Okay, so as the condition of destructive interference is satisfied, so therefore the pattern appears to be dark only. So therefore your central spot is dark due to reflected light. And if there is a question like if we can replace that reflected light by the transmitted light, so answer is yes, we can replace reflected by transmitted. So in that case your central spot can be a bright. Okay, so question can be asked like, can we get the central spot bright? So answer is yes. Answer is yes, we can get the central spot bright with the help of transmitted light. Okay, so if you can change that medium, so you can be able to get the transmitted light, and transmitted light, once they interfere, so they satisfy the constructive interference and they can produce the brightness. Okay, so in this way we can be able to change the pattern also if you change the light. Okay, so here we are discussing with the help of say reflected light. So reflected light, once they interfere here, so they produce the means they satisfy the destructive interference. So therefore they produce the central spot dark. Okay, so this is a broader central spot, and then after that there is a consecutive bright and the dark fringes. So why the fringes in a ring pattern or circular pattern? So that also I given is answer is simple. The fringes are in circular. It is because the locus, that is a fixed point, is at the center. So every time your fixed point is remains same, so therefore the ring which the pattern that appears to be in a ring or circular form. Okay, and then third important point, ki why the pattern appears to be irregular in the sense it is not equal pattern. Equal in the sense, if you are towards the center the distance is larger, and if you are away from the center distance is narrower. So simple answer, ki the central spot, that is the zeroth order, then after that you can be able to see the first order, second order, third order, and etc. So order of the fringes is increasing, but your theta, the theta means the angle of wedge, so the theta which is not been increased in the same proportion. So why it is not in the same proportion is because there is a curve part. So if you want to measure the theta, you have to draw the normal, and then you can be able to get the theta for a particular arc. Okay, so there is a arc structure. So due to this arc structure, the theta doesn't remain same for every pattern. Okay, so one pattern you have one particular theta, as the theta and the order of the fringes are not increasing in the same proportion, so therefore your fringe pattern is not in a equidistant manner. Got it? Okay, so these are the points that we have to conclude from the Newton's ring. Okay, so now this is the second example that we have seen. Now the next one, now you can see this diagram in a broader sense, ki this is what the half part of this convex lens, then this is an incident ray. Once it incident, there is a partial action. Due to this partial action, there is a two refracted rays which has been formed, that is ray 1 and ray 2. And these two, ray 1 and ray 2, they interfere and they will satisfy the condition of constructive and destructive, and you can be able to get the different kind of pattern. So here one example is given for a particular thickness say T. So there is a reflection which has been mentioned. Okay. So you can see the ray 1 which is reflected with no phase change. So you can see here the ray 1 which is a reflection is from the convex lens surface only. So lens surface means the medium is same. So therefore there is no phase difference. But if you focus on the ray 2, so the ray 2 which is reflected from the denser surface to the rarer. Okay. So here is the air medium, that is a rarer medium, and here the glass block which is a denser surface. So there is a reflection at point B from denser to rarer. So there is a phase change of pi. So these two rays, they have some phase difference. So due to this phase difference, so they can be able to produce the different kind of, means they can satisfy the conditions and they can be able to produce the different pattern like bright as well as the dark. Okay. So these are the conditions, and through this condition now there is a one simple derivation, that is the radius of curvature of the circular path. So radius of curvature, you can see this diagram. So this is your plano-convex lens, and the dotted line that indicate the radius of curvature. small r, that is the radius of the particular ring, means at particular position you will be able to get that ring, so that r. So in general you can say rn also. So n means if we are focusing on the first ring, so it will be r1. If it is a nth position, so it will be rn, like, okay. So in this way you will be able to get the different kind of pattern. So please see the diagram carefully. And just a second. Hello, yes. So we were discussing on the radius of the circular path. So here you can see this is your convex lens, and the path has been extended so that it can trace a circular. So r, capital R, that is the radius of the circular path. So from this simple trigonometry has been applied. So here this is your r, and this one is your simple. You can see this is r, and this is t. Okay, so this entire thing becomes the r minus t. Okay, now you can see the constructive interference condition, that is 2 twice t, which is equals to m minus 1 lambda by or m minus 1 by 2 lambda. So here directly they have considered ki the cos r is equal to 1, that is for normal incidence. So by applying that, so 2 mu t, so mu is also considered as 1 in this case. So mu is equals to 1 and cos r is 1, so therefore remain is only twice t. So twice t, which is equals to m minus 1 by 2 lambda for constructive interference, and for destructive it is 2t equals to m lambda. So by considering this thing, now if you want to find out the radius of the suppose say dark pattern or dark ring, so you can apply the destructive interference condition. If you have to find out the radius of the bright ring, so you have to apply the constructive interference condition. So simple, by applying the Pythagoras, that is r minus t square plus r square equals to capital R square. So in this case, after solving, we can see the r square, which becomes 2rt. So the remaining term that comes out, if you compare the thickness of the film with the capital R, so it is very, very less than. The thickness of the film is very, very less than. So therefore that t square term is neglected. So as you can see, for large r and small t, so therefore your final r square, that become m r lambda. As you can see, the twice t, which is m lambda, so you just simply have to substitute, so you will get the radius of the dark ring, that comes out to be r square, which is m r lambda. So m is the order of the fringes, r is the radius of the circular path, and the lambda is the wavelength of the monochromatic light. So if you go on substituting the value of m, so that will start from say 0, 1, 2, etc. So you will get say in terms of capital R, so these values. So sometimes the question can be asked in this way also, ki prove that the radius of the nth dark ring is proportional to the wavelength of light. Okay, so you should have to solve this. So there is a complete expression. So here only the some steps are mentioned. So what you have to mention in this expression part is, first you have to draw this diagram. In that diagram, what we are consider here, ki there is a particular thickness, that is t we are consider, and through this there is a r means it is a general form. Okay, you can put the nth term also, say rn. So if r equals n equals to 1, so that will be first dark ring. So for that particular ring, so r will be the radius of that particular dark ring, and capital R is the radius of plano-convex lens, the surface. Okay, so this is your radius of this plano-con. The total, you can say, the surface that we have drawn from the dotted line. So capital R is the radius of that. Okay, and small r is the radius of the dark ring. Okay, either dark or it may be bright also, whichever you consider. Suppose it is asked for say radius of dark ring, so you can consider dark pattern, and if it is say bright, so you can apply the condition of bright also. So that depends upon whatever question is being asked. Okay, then you can see some important points from this extract. So by D or beta is the same. That is, D is the fringe spacing, which is lambda upon 2 theta, 2 tan theta. As the thickness of the airframe increases gradually outwards, non-uniformly, the separation between the fringes decreases. So you can see the fringe spacing, that is D, which is lambda upon 2 tan theta. So here in this case, as the theta is varying and the beta, so therefore you can see once you are toward the center, once you are toward the center, the distance is larger, and if you are away from the center, distance is narrow. It is the simple reason that you can follow this fringe spacing formula, that is D, which is lambda upon 2 tan theta. So lambda, which is a wavelength of monochromatic light, and theta, which is varying. Okay, so the theta, as the theta increases, your D value that go on decreasing. So you can see there's a curve structure in diagram. So as the theta go on increasing, so your beta that also decreases. So that is one of the reason why the pattern is not equidistant. Okay, then second important point, if the white light is used, so color rings will be observed. So that is true. If you use the white light, so there is a color pattern for a given ring. The inner side is violet and outer side is red. So this is because the radius is proportional to the square root of the wavelength, and the red light has a longer wavelength. So these are the some tricky questions can be asked. If you replace the monochromatic light by the white light, so what type of pattern we can be able to observe? So the pattern appears to be the colored ring, and how it seems to be, so it seems like a inner side is a violet because it corresponds to the wavelength, because your radius which has a formula, you can see the radius of dark or bright ring, which is equals to m lambda r or m r lambda. So it has been directly proportional. Okay, so therefore you can see there's a corresponding wavelength that you can be able to see here. Okay, and then third point, if it is a dark spot at the center of the lens, so that already we have discussed at the center there is a dark spot, so the path difference of the two reflected light is 0, but there is a phase difference of 180 degree. So on the ray, and therefore the half of the path difference exists between the two rays, the destructive interference occur at the center. So you can see there's a destructive interference at occur at the center because simple answer, the two interfering waves they come out with a phase difference of 180 degree. Okay, and the path due to this 180 degree phase difference, the path that is been introduced is a lambda by 2. Okay, and 1 lambda by 2 or 3 lambda by 2, so that is the condition of destructive interference, that is odd integral multiple of half wave. So therefore the center spot that appears to be dark only. Okay, so these are the some important points from this Newton's ring experiment setup. Okay, then then further some important, so if the interference pattern is viewed from below the glass block, so the reverse bright and the dark fringes will be observed. That is, the center become bright spot. This is because of the two 180 degree phase changes due to the ray reflected twice by an optical denser medium that the transmitted rays are in phase. You can see the statement that we are given here, what it has been mentioned, the interference pattern is viewed from the below the glass block. So you can refer the diagram below the glass block. You can see the below the glass block, the ray that is coming is a transmitted ray. Okay, these are the transmitted, you can see the diagram also, this one. So below this glass block, This is your transmitted ray. Okay, so the transmitted ray, they interfere or they come out with the no phase change. Okay, so no phase change. So means no phase change means one will come with the 180, another will also come with the 180. So ultimately the resultant will be 0 or 360. Okay, so therefore if these two ways they interfere, so they will produce the point of maximum. Okay, so next point, as the ring produced by the transmitted ray are complementary to that by the reflected light. So that is constructive. So just now I mentioned ki if you are using a transmitted light, so you can be able to produce the rings that is pattern with the central spot bright. Okay, and this is due to only the constructive interference. Okay, so these are the some important points of the Newton's ring experiment. Okay, then next is the application. So application of Newton's applications of the interference, that is optics chapter. So here the most important application is the anti-reflection coating, the anti-reflective coating. So you can see the anti-reflection coating. So for that, there are the three mediums that we are consider in this particular diagram. You can see there is N0, N1, and NS. Okay, you can see here there are the mediums. So here N1, NS, and N or N naught. Okay, so here is you can just see the statement what is mentioned here. So your glass eyeglasses, possibly and sophisticated multi-element optical systems like telephoto lens rely on the anti-refractive coating to reduce the extraneous images, loss of contrast, and other image degradation due to the unwanted reflection. Now, what does it mean? So, it simply indicates what is the need of anti-reflection coating. So, why we require the anti-reflection coating? Okay, so the anti-reflection coating is particularly required for the quality of the image. Means if whichever the image that you are getting, if it is not a quality image, so you can be able to produce the quality image by using the anti-reflection coating. Okay, so the anti-reflection coating, so in means in optical instrument, the part of the light incident on the glass surface is reflected backward. Okay, the part of the light incident on the glass surface is reflected backward, so which may be amount for the loss and reduce the quality of the image form. Okay, so to eliminate these reflection, the anti-reflection coatings are being used. Okay, so to eliminate or to suppress, you can say, so the whichever the loss of contrast or image degradation, so all these things that we can able to resolve with the help of anti-reflection coating. So basically what is anti-reflection? So in particularly the optical instrument, so in optical instrument, the part of the light that incident on the glass surface is reflected backward. Okay, so to reduce this reflected backward light, okay, or unwanted reflection that we have mentioned, so the glass surface which has been coated by the material, and that material can be anti-reflection coating. So now next statement, you can see the straightforward application of thin film interference, the coating of silicon oxide or magnesium fluoride MgF2 or other hard, transparent, and easy to apply in a thin uniform coating, that is by the method of vapor deposition. Okay, so there is a particular material which is to be chosen so that that material can be coated by some method, and that some method is a vapor deposition. Okay, so the vapor deposition method which has been used to coat this kind of material on a glass surface. Okay, so that it can work as an anti-reflection. So you will not miscoat any sort of material, so that it can work as a anti-reflection. So there is a criteria. So what should be the criteria so that it can work as an anti-reflection? So the refractive index that has to be chosen properly. So like suppose if you take example of say MgF2, the magnesium fluoride, so the lenses are coated with the thin film of this transparent material, that is MgF2, and means in order to reduce the reflection from the glass surface. Okay, so using this material, at least we can be able to increase the quality of the image. So there is another example, that is cryolite. So cryolite and the MgF2. So MgF2, which has a refractive index of 1.38, and the cryolite, which has a 1.36. Okay, so if we assume that the light strikes the lens, okay, you can see here the diagram. There is a light which strikes the lens at the near normal incidence. You can consider, say, these are the waves that will incident normally. So right now it is mentioned the waves that is incident on this particular surface. So here, the second point, if you look at, so n or mu, you can use for the refractive index. So here is the refractive index of air, then refractive index of the coating material, and the refractive index of the glass. So there are the three refractive index. So the material which we are going to coat, that is between the air and the glass. Okay, so that is the one condition that you have to remember. The material which we are going to coat, it should have a refractive index between the air and the glass. So as I mentioned, the MgF2, if I chosen MgF2, the magnesium fluoride, so which has a refractive index of 1.38, and the air which has a refractive index of 1, and the glass, it ranged from 1.5. Okay, so therefore your coating material which range between 1.38 or 1.36. Okay, so such type of material which we are choosing for the coating, the anti-reflection coating. So you can see what the difference will make here. So if you focus on these two mediums, like say air and coating, so your air become a rarer medium and the coating become denser. Now if you choose the two mediums, like say coating and the glass, so in this case the coating becomes your rarer medium and the glass become your denser medium. So please try to understand there are the two phases. Okay, one is between air and coating, and another is between coating and the glass. Okay, so if you comparing this at a time, we are not comparing three. For first you have to compare the two, because the ray will incident from one medium to other, and then from other to the next one. Okay, so in this way we have to observe how the rays will come out. Okay, so what will happen, the resultant path difference, that becomes zero. You can see once the ray will incident to the near normal incidence, so there is a phase change of pi that is associated with each ray. Okay, so each ray with associated with the phase change of pi. You can see, suppose this is a ray which is incident on the surface. So once it will incident, it get reflected back. So the reflection is from denser to rarer. So there is a phase change. Okay, and then if you think about the other ray, so other ray which also introduce a phase change of pi, it is because there is another medium which is more refractive index than the previous one. So therefore there is also a phase change of pi. Okay, so both the rays that will come out with a phase change of pi radian. Okay, that we are not observed in case of uniform thickness. So in uniform thickness, the third part, that was also air medium. Now here the third part is a denser medium. If you compare with this the previous thin film diagram. Okay, so that is the main difference you can observe here. The material which we are coating, so that should lie between air and the one of the denser medium or glass, you can say. Okay, so in this way, once the beam will incident on the surface, so the two rays that will be generated, but both the rays, they will come up with the phase change of pi radian. So if they interfere, so their resultant will be a zero phase difference. Okay, if the zero phase difference, so it means your quality that becomes increased, the quality, because if the rays that come out with no phase change, so naturally we will satisfy the condition of brightness, and you can be able to get the what you can say, the image with the quality. Okay, so the thickness lambda by 4 for the base transmission, that distance enough for reflection. So where the lambda is the wavelength of the film, so explicitly, so lambda film, which is equals to lambda air by n. So single layer coating optimized for one wavelength, typically 550, nearby 550 nanometer, yellow oblique green. So visible color in white light is yellow. Okay, these are the different they assume ki if, as you can see, there is a purple color mostly we are observing for the spec lens or say camera lens. Okay, so it is because the visible color in white light, that is between this, that is white light, that is yellow oblique green. So therefore nearly approximately we are observing the purple color, that is the reflection. Okay, so why there is a purple? It is because the MgF2, the magnesium fluoride, that reflect the purple color. So here, what we can conclude in the anti-reflection. So first thing, ki what is the need that you have to write? Ki why the anti-reflection coating material is required. So as we have discussed, ki anti-reflection coating, because first you have to identify the problem. So problem is ki mostly in the optical instrument, the part of the incident light on the glass surface is reflected backward. Okay, so due to this, the quality of the image that get reduced. Okay, and even though you can be able to lose the or there's a loss of contrast as well as the image degradation. So to avoid this image degradation or the quality, to maintain the quality of the image, there is a need to suppress this back reflection. Okay, so this suppression job, which is to be done with the help of anti-reflection coating material. Okay, so there are materials like say MgF2 or silicon oxide or cryolite. So these are the hard materials which are being coated on the glass surface. So these materials which are being coated by the method which we call as a vapor deposition. So with the help of vapor deposition method, these material which has been coated on the glass surface. So now the while choosing this material, their refractive index is, it should be between the air and the glass. So for example, if we take the example of say MgF2, so magnesium fluoride which has a refractive index of 1.38 and the air which has a refractive index of 1, and sorry, and the glass which has a refractive index of 1.5. So therefore your MgF2 can work as an anti-reflection coating. Now by mathematical condition, how it can satisfy to get the quality image. So for that what we did, we have incident a beam of light on a surface of the coating material. So once it will incident, so there is a reflection, there is a partial action, it get partly reflected from the coating surface to the air medium. So as the coating which work as a denser medium between the two, if you compare the air and the coating, so in this case air is a denser rarer medium and the coating will be a denser medium. So there is a reflection from denser to rarer, so it generates a phase change of pi radian. Okay, similarly it also reflect from the glass surface to the coating medium. So due to this there is also a phase change of pi radian. So both the rays, they come out with a phase change of pi and pi. So equally once they interfere, so their interference will produce the resultant phase change, that is 0, or you can say the 2 pi. Okay, so if both the ways they interfere in phase, so they will intersect constructively, and due to constructive interference the quality of the image that can be increased because you will get the maximum intensified image. Okay, so this is what the anti-reflection coating will work. Okay, so this is one of the important application, and your minimum thickness that is required is lambda by 4 times mu s. Okay, so minimum thickness for getting the quality image, the T minimum, which should be, that is lambda upon 4 times mu s. And second, the condition of refractive index, that is coating material should lie between the air and the glass. Okay, so these are the mandatory condition to get the anti-reflection. Okay, then uh, this is about the surface testing. So how you can be able to get the different surface testing, you can see here. Now, this is second application, important application, and mainly this application which is used in the industries. Okay, so you can see the checking of optical flatness using optical flat. Okay, so checking of flatness using the optical flat. Optical, it means because we are checking the glass surface. So you can see here, if the glass surface which has a structure like this, so you can perform the experiment and you will be able to get the kind of pattern like this, somewhere here or some sort of this. So if you have a convex surface, so you will get the pattern in this manner. If you have a concave surface, so you may get the pattern like this. If you have a flat surface, you will get the pattern like this. Okay, so in this way we can have a experimentation and we can be able to test the surface, the optical surface. Okay, so this is one of the important applications. So you can see here one by one. A perfectly flat surface will show the straight and equally spaced band. So you can see here this. So that is your air wedge experiment. Okay, so if you have a perfect flat surface, so immediately you will get the pattern that will be a straight equidistant line. Okay, the straight equidistant vertical lines means the pattern. Okay, if you are getting a straight equidistant pattern or bands, so that indicates your entire optical surface is flat. Okay, it is totally flat, means there are no flaws or any defect. Okay, the second is a convex surface displays a bright patch in the center, while a concave surface displays a dark patch in the center of the pattern. You can see here there are the two diagrams which is given. So the convex surface displays a bright patch in the center. So convex, if there is a convex surface, so there is a bright patch in the center, while the concave surface is there, so it displays the dark patch in the center. So it depends upon how the point of contact. Okay, so it depend upon the point of, so when if there is a convex surface, so it will be able to means the surface that has been touching to the glass layer, so here it appears to be the bright, and if it is a concave surface, so it appears to be a dark patch at the center. And also it depends upon the light which we are using, whether it is a reflected or it is a transmitted, so accordingly also pattern can change. Okay, then testing using the finger pressure. You can see the finger pressure. So finger pressure, it means the convex, if an edge is subjected to the pressure, the flat with roll about the apex. So you can see there is a apex point. If you press at the apex point, so you can be able to get a structure like this also. So you can be able to observe with the help of while performing the experiment, you can see how the pattern is changing. If you see the assembly of the Newton string, so in that assembly there is a screw arrangement which has been given. Okay, if you can tighten the screw, so hopefully you can be able to see the how the center spot is also been shifting from one place to other one. Okay, so that also gives a indication key how we can be able to check the optical surface. Okay, so this is one of the good example for the surface testing. Okay, then this part I left to you, the branch specific application, because the students are from the different branches. So I given an example here ki what are the applications. So I expect ki at least you should go through the material, or you can have a search and you can have a means preparation, so that we can have this as a TA number 2. Okay, so TA2 will be based upon your branch specific applications. Okay, so whichever the this what you can say, the questionnaires that we are going to raise, or maybe some instruction that will be given for TA2, so that will be based upon your branch specific. So for that, this is one of the hint. So just see the electromagnetic wave approach. So those who are from say ENTC branch, so they can be able to go for say electromagnetic wave approach. So wave, which is a part of optics chapter. Then photoelasticity effect, digital image correlation. So these are all electronics and telecommunication, fiber optic sensors. Then metamaterials. So these are the mechanical applications. So they can be able to use for the non-destructive detection. So non-destructive testing. So mainly is been used for the fossils. The fossils that can be means without any destroying, you can have some observations, so that we call as a non-destructive method. Okay, then for civil engineering, the monitoring of civil structures infrastructure using the fiber optic sensors. Okay, and then lastly for the computer branches, computer or IT soft branches, so there's a optical computing. So these are the various branch specific applications where you can be able to approach the optics. Okay, so how the optics can be applicable in a different engineering branches. So these are the examples that I quoted. So I left to you. You can go through it. You can have more number of applications also. So that is your as an assignment you can consider. So that means we can verify later on, or you can be able to submit if you have some sort of the material related to this. So you can be able to share on a Google Classroom with your roll numbers also. So this is what the unit number 2 optics. If you have any questions, please raise. And there are some numericals which is left. So maybe in the next lecture we can be able to complete some numerical based upon the Newton's ring and the anti-reflection coating. And yesterday we have solved with the air wedge numericals. So in one lecture, maybe next we will wind up our syllabus. Okay. Then remaining lectures, we will have a revision on both the units, unit 1 as well as unit number 2. Okay?
सर
Yes. Any questions if
सर
you
ऑफलाइन
have?
सर ऑफलाइन कॉलेज कब से शुरू होगा सर?
Offline we have started, but the student strength is very less. So therefore, it has been conveyed कि you have to start with the online because hardly 10 to 15 students are in the class. So it becomes very difficult to manage both the shows.
ओके सर.
Okay, so if by today we will get the confirmation about the CA also, okay, whether the CA will be conducted in online or offline. So that we will percolate the notice, and then after that we can have a decision also. Okay.
सर पेपर पैटर्न क्या रहेगा सर CE1 का फिजिक्स का?
वही वही मैं बता रहा हूँ. पेपर पैटर्न जो है आपका कैसे है कि अभी आज कंफर्मेशन होगा कि वो ऑनलाइन में होगा या ऑफलाइन में होगा. बेस्ड अपॉन दैट द पेपर विल बी मीन द पैटर्न विल बी लाइक यू आर आस्किंग अबाउट द मीन्स मास डिस्ट्रीब्यूशन और व्हाट.
सर यस मास डिस्ट्रीब्यूशन सर कैसा होगा सर
मास
उसमें?
डिस्ट्रीब्यूशन विल बी इट इज ऑफ टोटल 15 मास. 15 मास का रहेगा. 15 मास. ओके. हेलो. So there is a equal distribution to both the units. Okay. And there will be an internal 20% choice.
Types of questions.
Huh?
Question type कैसे हो?
Type means it will be descriptive as well as it is totally based upon your like say Bloom taxonomy. So Bloom taxonomy says like there may be some question based upon your knowledge level. So some definition part, some explanation, some derivations and numericals. So all these parts, and lastly application also. So your question will cover all 4 pattern. One is your knowledge, means if there are some definition like suppose you can have say thin film, or what is thin film. Okay, it will not be like the defined thin film. So what are described about the thin film? So you have to write at least 2-3 words about what is thin film, give a proper example. So this kind of question can be asked for say 1 or 2 marks. Then there will be some expression like you have to derive the expression for say parabolic path. So that can be of say 3 or 4 marks expression. So likewise means you will get the questions descriptive as well as both. Even some questions maybe you have to draw only the diagrams with the proper labeling. So diagram of say maybe say Newton's ring experimental setup with a proper explanation. So you have to draw the diagram. So likewise this question. So already the question bank of electron optics I shared. Today I will share the optics also, the unit number 2, all question bank. Even the numerical banks, I will scan my sheet and I will upload that sheet also on your this Google Classroom. Okay. So you start your preparation. So that means you can be able to get the good marks in the CA examinations. Okay. Any more queries?
सर ऑनलाइन कब तक शुरू रहेगा सर?
ऑनलाइन जब तक आप नहीं आओगे ऐसा है. कैसे हो
सर
रहा है कि
सामान ने बोला है सर 1 तारीख से शुरू होगा सर. ओके सर.
नहीं क्या हो रहा है अभी देर इज नो मीन्स ऑफिशियल नोटिस और सर्कुलर. ओके. सो देयरफॉर द पीपल आर आल्सो इन अ डिलेमा कि वेदर वी हैव टू अटेंड द ऑफलाइन क्लासेस और नॉट. But it has been instruction from the director sir also कि you have to attend the physical classes. So we have observed that till today hardly means if I count overall all divisions, so hardly say 15 to 20 students are approached in the classes. So it becomes difficult to conduct for these students also because there are different subjects. so hardly one or two students are sitting in the class, it becomes difficult. So इसलिए अभी online start किए हुए. So it is more convenient to go for the offline because there are some numerical portions, there are some circuit diagrams are also there. So it becomes difficult to explain also in online mode. Okay. So we are putting 100% efforts. You are also taking the 100% effort, but still there should be some what we can say, the interaction. Okay, because once we interact, then and only your difficulties will also resolve. So we are by today we will try to convey regarding the CA. So if CA will be in offline, so you have to 100% you have to report to the college. Okay.
Okay, sir.
Yeah. Okay.
Okay.
So
Thank
I
you, sir.
hope there are no more questions. Okay, then. Thank you. We'll close this meeting.
Sir.